equations and inequations. So we finished the expressions. We're looking at equation, inequations. Now equations, equal sign. Inequation is where we have the inequality sign like these, right? All right. Once we replace the equal sign with those, we now have inequations. But the same method, same process, except one or two minor differences. All right. So using the quadratic formula, we're looking at equations here because we have equal sign, so that we're looking at equations. It says using the quadratic formula. And quadratic formula, when we think about quadratic formula, we're talking about expressions of this format, where we have the ax squared plus bx plus c, where a, b, and c are members of real numbers. Oh yeah, and a is not 0, by the way. A can't be equal to 0. Because a is 0, then 0 times x squared will be 0, and then we'll have a linear term. We don't want that. So for these, we're asked to determine the roots of the equation. Now you might be saying, but I thought we're not working with those that have a higher number than 1 before the x squared. I thought we just have 1 before x squared. But the thing about it is that we're looking at using this formula. So we're not focusing on factorizing. I mean, if you can factorize, you can use the factorization method and solve, but not all of them can be solved by factorization. But majority will be solved by using this formula. So that's what we're focusing on, using this formula to solve, to find what we call the roots of the equation, or the x-intercepts. So that's a different name, right? Roots of the equation, quadratic equation, is also referred to as x-intercepts, or the solution to the quadratic equation. So what we do, let's look at the first one, being 2x squared equal 3x plus 2. What you want to do is to have the equation equal to, look at the form here, 0. Why 0? So that we can actually take it and put it in the quadratic formula. So we must have it equal 0. Now to do that, what we need to do is to transpose all the terms from one side to the other side, so that we can actually have the expression equal 0. So we write the 2x squared that we have there so far. The 3x will be transposed from the right hand side of the equal sign to the left hand side. Now because it's a positive 3x, it will become now what? A negative 3x. This plus 2 from the right hand side of the equal sign will be transposed to the left hand side of the equal sign, and we'll have a minus 2. And so all we have on the right hand side is 0. Once we move everything over, we have 0 on that side. Right? So we still have an equation, just 0 on that side. Now it's actually in the form of what? Ax squared plus bx plus c equals 0. Are you seeing that, guys? It's now in this form. Ax squared plus bx plus c equals 0. All right? Can you guys see that? So here's my question. What is a? What is a? A is a number. What is that a? Look at this. Right? We equating the coefficients. A is equal to what? I heard it a while ago. 2. B is equal to what?
2. 3.
Not 3, but what? Positive B is equal to negative 3. Positive C is equal to what?
Negative 2.
Negative 2. You have to take the sign in front of it. Yes. All right. Next step is now. So the thing is, we got the equation right here to be equal to 0. But in order for us to use this quadratic formula, which is, we must identify the values for A, B, and C. Because if you notice, this quadratic formula actually use what?
So I have a question.
Yeah.
Where you got negative 3x from? No, I just not understand.
Okay, that's fine. We have 2x squared equals 3x plus 2. In order for us to solve a quadratic equation, quadratic means the highest power on the variable x is 2. Notice this x has a 2 on it as a power. This x has, we're not seeing anything, so it's a 1. So it's a linear term, and this is a quadratic term. But because we take the name for the highest one, we call it a quadratic. Now for every quadratic, sorry, write this back. For every quadratic equation, we solve, the equation must be equal to 0. Right now, what are we seeing here? 2x squared is equal to what? Is it equal to 0 or equal something else?
It's equal something else.
So to get it to 0, we need to remove the 3x, positive 3x, and remove the positive 2. Right, and let me use a longer method to explain. Use a balanced method. So I need to remove this 3x from here. What do you think we're going to have to do? I have to subtract 3x from this side. So it's cancel it out from this side. So I'm left with 2 on this side. But I have to also take what? 3x from this side as well, right? But 3x cannot come out of 2x squared. So I simply just write it as 2x squared minus 3x equal 2. But now I need to get rid of this 2. But it's a positive 2. To get rid of the positive 2, what do? I subtract 2, right? It is cancelled. 2 minus 2 is 0. But then I need to subtract 2 from this side as well. So I'm left back with is the 2x squared minus 3x. Because the 2 cannot be subtracted from these two terms. They are unlike terms. But I can still write it as a minus 2. And on this side, I have 0. So that's how the minus 3x appears. From having 3x on this side, the right hand side, sorry, to now having negative 3x on the right and left hand side. It's just that I subtracted 3x from the right hand side because we're trying to get rid of everything on the right hand side. Because the plus 3x, we use minus 3x to get rid of it. But we had to do it to both sides. And because I subtract 3x from this side, that is the left hand side, I'm now seeing 2x squared minus 3x. Because 3x cannot come out of 3x squared. They're unlike terms. Only when I find out what x is can I subtract it from the other term. And to get rid of this 2, I also subtract 2 from this side, as I did in this step. But because I subtract it from this side, to keep it balanced, to keep it equal, to keep both sides equal, what I do to one side, I must do to the next. So I also subtract 2 from this side. So I have 2x squared minus 3x minus 2. So that's how we end up with this. But a faster way of explaining this is that in an equation, once we transpose a term from one side, so we're trying to get 0 over here. We're trying to remove 3x and remove 2 as well from the left hand side of the equal sign, from the right hand side of the equal sign. So 3x goes over as what? Not just the 3, but 3x as collectively as one term goes over as from plus 3x to minus 3x on this side of the equal sign, the left hand side. So I have this as the left hand side and over here as the right hand side. So the 3x moves from the right hand side to the left hand side from plus 3x to minus 3x. The plus 2 moves from the right hand side to the left hand side as minus 2. So because I move the 3x and the 2, I'm left with 0 on that side. Was that clear?
Yes, sir. Thank you.
All right, no problem. Yeah, I put there. Okay. So now we understand how we got this, right? The same thing I have here. So I basically write the form ax squared plus bx plus c. Why did I do that? So we can line up the a, the b, and the c. All right, and they both equal 0, right? So what is my a? My a is 2. So I write a equal 2. What is my b? My b is negative 3. So I write b equal negative 3. What's my positive c? It's negative 2. And I put that. Now, this allows me to replace the a, the b, and the c in the equation with these values. Right? So I'm going to put x equal, of course, you know you're going to substitute it, so that should be fine. But negative b, so negative b is actually negative 3, right? And be careful with this. So you have a negative 3 here for b. Don't think that because you have this negative here or anything. No, no, no. It's negative, or the opposite of what b is. Positive b is what? This is a positive b, you know. Positive b is negative 3. Positive a is positive 2. And positive c is negative 2. We're given what b is, positive b is. Now we want to find what negative b will be. So if positive b is negative 3, that means negative b should be the reverse, the opposite, positive 3. But let's see if we get that. I'm going to put a bracket around b, not the negative, but around b itself. Right? So put a bracket here and replace it. Put a bracket here. Replacement. Replacement. So wherever I have b, I'm going to put what? -3. Plus or minus the square root of b squared minus 4a times c over 2 times a. And where I have b, I put -3. Where I have a, I put 2. Where I have c, I put -2. Where I have a, I put 2. Okay, are you following so far?
Yes, I am.
Okay, tell me what to put here now. We're just going to work this out. So the plus and minus, we're going to put that back. We're not going to use the square root sign as yet. We put it back until we're ready to use it. We're going to work out everything else. Now here's the thing. In your calculator, just put this. Tell me what you get. Put the negative, put open bracket, put -3, close bracket. What do you get for that? I mean, you can use your head and do it, but use a calculator for now. What's your answer?
+3.
+3. So I'm going to put
+3.
right, so I'm going to put a +3 here. Next, what I want you to do, I want you to put this entire thing in your calculator. Negative, open bracket, -3. Make sure it's in the bracket. And put a square outside. Then -4, open bracket, 2. And open bracket, -2. Put all of that in your calculator one time. All of that. Don't break it down little. Minimizing errors. What do you get?
25.
25. Okay, and let's check that. The square of -3 is 9, positive 9. Now this is negative times positive times negative. So negative times positive is negative, and that negative times negative will be positive. 4 2s, 8, and 8 2s, 16. 16 plus 9 is 25. That's correct. Over 4. 2 2s, 4. Alright, I'm going to work out this portion here between the equal sign. So I'm going to put back my division line over 4. Now I cannot do anything with the 3. So I'm going to just leave it as +3 plus or minus. What is the square root of 25? Now, do not put back the square root of 25. We need to work out what the square root of 25 is. When you work it out, you should not put back the square root symbol.
5.
5. Should I put square root over 5? I'll put just 5.
Just 5.
Right, just 5. If I put the square root over 5, it means I have to find what the square root of 5 is. And that's not what this is telling us. The instruction here is to find the square root of 5. Once you use the square root sign or symbol, you do not use it, you don't put it back again. We already use it. So we keep putting it back until we're ready to use it. And there's another common error. Ensure that the division line start from -b right up to the end. We'll keep on doing that. Right? Only thing the division line doesn't cover is or goes under is the x equal. Now we're at a stage where we cannot divide by 4 because we have a plus and minus sign blocking two numbers at the top. So what do we do there? Anybody remember? Anybody remember?
Either or.
Yes, we say either or. So we say either x is equal to, we'll take the plus in one instance, so it's 3 plus 5 over 4. Or in another instant, we take the what?
The -5.
The minus 5. And we work them out simultaneously. So we're going to say x equal 3 plus 5 is 8 over 4. Or 3 minus 5 is -2 over 4. What's 8 divided by 4? How many? Just 2. Just 2. Alright, because remember, what will happen here is that 4 goes into 4 once, and 4 goes into 8 twice. And 2 divided by 1 is simply 2. What about this one? Put -2 divided by 4. And press your ABC button when you're done to see. If you give a decimal, press your ABC button. Okay, put this, -2 ABC. right? And then 4. If it's not working, use bracket around the two terms.
I got
Negative,
-1/2.
negative 1 over 2, right? Negative a half.
Half.
Yeah, negative a half. So we have two values for x, or x equal to negative a half. All right, or what you could do with this, 2 into 2 goes once, and 2 into 4 goes twice. So notice in one instance you have 2 in the numerator, 1 in the denominator. When the 2 is in the numerator, it's just 2, because every number or every quantity can be written as that quantity over 1. So we can ignore the 1 and put 2. But when the 2 is in the denominator now, you're saying you're dividing 1 into 2 parts. So really have a half, really. All right, or 0.5. But it's best to always leave the answer as fractions. All right, so that's that. Everybody understand that one?
Yes, sir.
All right. Let's look at the next one. 3x squared plus 1 equal 4x. What do we do there? Let me just double check to make sure we have that one correct. 3x squared plus 1 equal 4x, yeah. Okay, that's part 2. What do we do here? If you remember the steps. It must be written in the form of ax squared plus bx plus c equals 0 in order for us to use the quadratic formula, right? So what do we need to do here? Talk to me.
Bring the 4x over to the other side.
Right. So we can now have
And
equals
it
0.
becomes -4x. Yeah.
Right. Where do I put the
And
4x though?
3x
After
at
the
the
1 or
end of
before the 1?
before the 1.
Right. Look at the formula. Right. Look at the form. Let me repeat it again. We have 3x squared plus 1 equals 4x. We want to have it in the form of ax squared plus bx plus c equals 0. And so what we need to do, we need to transpose this 4x from this right-hand side of the equal sign to the left-hand side of the equal sign, which is over this side. So that over this side we'll have 0, just as in this format. When the 4x is transposed to the next side, what we in fact have is 3x squared. We'll put the 4x, once becoming negative 4x, in the middle. And this plus 1 at the end. So we want the x term, the term in x, to be in the middle, just as we have this term in x in the middle of these two other terms. The x squared term, as in the 3x squared, goes first, and the plus 1, which is a constant, the one without a variable, as in the plus 1, goes at the end. And then we want to have equals 0. Of course, it's now equals 0 because we remove what was over this side. Now that it's in this form, we can actually equate the coefficients in a, b, and the constant c. So let me just line it up. Ax squared plus bx plus c equals 0. So we can clearly see that what? What can we see? We can see that the a is what? 3. The positive b is what? 4. And the c is what? 1. So we have a equal 3. We have b equal -4. And we have c equal a positive 1. Which means now we can actually use what is known as the quadratic formula. What's the quadratic formula? It's given to us as x equal -b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Alright, so let's punch in our values now. Trying to create some space there. So x equal, this will go on the next step, right? In the next. Next step, or underneath, I should say, this step here. So replacing the what? What are we going to replace? We're going to replace the b. Replace this b here, minus 4. Replace the a and the c, 2 times a. Somebody have a question?
No, it was by accident. My bad.
That's fine. All right, so we're replacing b. What goes inside the bracket? Remember, this negative b is part of the formula. This negative does not belong to what we have here. This negative b is part of the formula. So I put the bracket and keep the negative out. So what is b? B is equal to what?
Negative 4.
Right, what goes here?
Negative 4.
Yes. That sounds like Javier. What goes here?
Yes.
What goes here?
3.
And what goes down here?
3.
What goes here? For C?
1.
Right, very good. All right, so let's work out the next part. So x equal. What's the negative of negative 4? What's the negative?
Sir, can you please excuse me for one moment? I'll be back.
Oh, sure. What's the negative of negative 4?
Positive 4.
Right. So negative negates the signs, right? When negative is outside the bracket, it changes the sign of those in the bracket. So it's going to be positive 4. Or I can put it in the calculator, negative open bracket, negative 4, and you'll see that you get positive 4. Plus or minus, and you guys are correct. What's the square of negative 4? Ensure negative 4 is within the bracket. But by the way, put this entire thing in the calculator, what would you get?
4.
The whole answer before?
That's what I got.
Okay. So when you put negative 4 to be squared minus 4 times 3 times 1, you got 4. Well, the square of negative 4 means what? It means negative 4 times itself. Just like anything you're squaring, once it's in the bracket, the negative times negative is positive, and 4 4s is 16. Now we need to subtract from that what amount? 4 times 3 times 1. 4 times 3 is what? 12? And 12 ones is still 12. When we subtract that, we get 4. We have more positive than negative, so answer is just 4. And you correctly stated that. Next step, x is equal to what? 4 plus or minus. What is the square root of 4?
2.
2. Should I put the square root symbol back again, or should I leave it off this time?
Leave it off.
Leave it.
We have to leave it off because once it's an operation, so once we use it, it's no longer there. Just like when we say square of negative 4. Yes?
For the denominator, you have 2 and it's supposed to be 6.
Oh, yes.
For the denominator, yeah.
Yes, that's correct. That's correct. Thank you for spotting that. For the denominator is actually 2 times 3. And that should be 6. Thank you. And I get 100 for that test. Imagine that. Okay, so let's look at it now. So square root of 4 is what? 2. Thank you for spotting that, Anisha. It's going to show that. Make sure you look over the work when you have finished, right? Especially if you finish ahead of time. So x is equal to. Oh yeah, I'm doing something here that I wouldn't want to do. I need to examine what I have. Let's look and see what I have here. Can I do anything with the numerator? Can I add a numerator here? Just like that? What would I need to do here? What would I need to do here?
Either or.
Use the either or, yeah. So we're going to say either Miracle, you back with us? Okay, that wasn't Miracle. I thought that was Miracle. All right, so we're gonna use the either or. So either what? Tell me.
4 plus 2 over 6.
6.
4 plus 2 over 6. Right, Mikhail? And that will give us what, Mikhail? Our Angel. 4 plus
6 over 6.
6 over 6, which is what?
1.
Right.
X equal 1.
And this will be 4 minus 2 over what? 6, right?
6. Yeah.
What's that answer?
That'll be 2 over 6.
2 over 6. And that can be reduced as what? Would that be 3 or 1 over 3?
50.
Think about it. Would it be 3 or 1 over 3?
1 over 3.
1 over 3. Page? Alright, so this is going to be what? 2 into that goes once, 2 into that goes 3 times. And so what you have here is what? X equal what? This implies that x is equal to a third. So there are two values for x. 1 and a third.